Welcome you all in lecture number 26 of Engineering Mathematics 1 MTL 1025. In this lecture, we are going to discuss about the double integral, change of order of integration of integral, change of order of integration, right? After changing the order of integration, evaluate the integral and then triple integral. So let us see one simple example of double integral. See, evaluate this integral 0 to pi and 0 to x sin y dy dx. Right? One natural question is that in this integral, with respect to which variable we have to integrate first. See here, this is dy and dx. Right? Order is not necessary. Suppose dx dy is given, it is not necessary to evaluate first this and second this. Right? It depends on this one. Suppose if this limit is constant, a to b and c to d, right? Then evaluate this integral in same order, dx and dy. Okay. If this limit is not constant, like here, now then we have to see the limit is function of x or function of y. If limit is function of x, now we call this one as internal integral and this one is external integral, right? So first is internal integral, okay, right? If internal integral limit is function of x, then integrate it with respect to y, integrate it with respect to y and vice versa. Okay, so this rule is, and what is the second integral? Limit of second integral is constant. Limit of second integral is constant. Second integral, or we call it external integral, is constant. Okay, so see the example. The limit of internal integral is 0 to x, that is function of x. So we have to evaluate this with respect to y. Okay, then what is sin y dy? Integral of sin y is minus cos y. Put the limit 0 to x. Okay, minus cos x minus cos 0. Okay, so minus cos x, this minus is also here, this become plus. Okay, so cos x minus cos 0 and take minus outside, and then evaluate this. What is cos 0? Cos 0 is 1. Okay, so this integral is converted into two parts, 0 to pi cos x dx plus 0 to pi dx, right? What is the integral of cos x? That is sin x. Sin x 0 to pi, then sin pi minus sin 0, sin pi is 0, this is equal to minus sin pi minus sin 0, okay, plus pi minus 0. What is sin pi? 0. What is sin 0? 0. So first term is 0 and second term is pi. So answer is pi. Okay. The integral is not tough. The integral is easy, but we know how to evaluate the integral. Okay. With respect to which variable we have to evaluate the internal integral, and with respect to which variable we have to evaluate the external integral. Okay. Now let us again see. See this limit. This limit is function of y. Limit is function of y. So we have to evaluate this integral with respect to, first evaluate the internal integral, right? Integrate internal integral with respect to x. Since it is function of y, so evaluate it with respect to x. Okay. The limit of external integral is 0 to root 2, so 0 to root 2, and evaluate this one. Okay, so integral of this is x, and what is the limit? Minus 4 minus 2y square and 4 minus 2y square. So what is this? 4 minus 2y square, so 4 minus 2y square, and minus, this is again minus, this is plus 4 minus 2y square. Okay, so what is this? This is 2 square root of 4 minus 2y square. Okay, so this is 2 into 4 minus 2y square. Okay, y dy. Then this thing, then evaluate this integral. So putting 4 minus 2y square is equal to a new variable, say t, right? Then minus 4y dy is equal to dt. Okay, then 4y dy is equal to minus dt. Okay, then 2y dy is equal to minus dt by 2. So put it here. See this integral, right? If lower limit is 0, that is y is 0, then what is t? T is 4. If upper limit, what is upper limit? Upper limit is square root of 2. Put square root of 2 here. Then 2 into 2, then 4 minus 4 is equal to 0. Upper limit is 0, right? What is 2y dy? 2y dy is equal to minus dt by 2. dt by 2. Okay. What is this square root? This square root is t. Okay. Then this becomes 0 to 4 root t dt by 2. Okay. So evaluate this integral. Now this integral is this one. Okay, so limit is change and change this minus sign, 4 and 0. Okay, so this is 8 by 3. So the value of this integral is 8 by 3, but we evaluated this integral with respect to ex first, with respect to dx, and then dy, and previous one with respect to y and then dx. Okay, now see the example here. What is the what is the value of this double integral? Value of this double integral, okay, dx dy, where d is bounded by this curve. Okay, in such type of problems we will know what is the curve given and what is the region bounded by these curve, those curve given in the problem. So see this problem, solution is this one. We have to evaluate d x square plus y square dx dy, right? What is d? D is bounded by the region, y is equal to x and y square is equal to 4x. Okay, so the double integral y square is equal to 4x is this parabola. Okay, this parabola y square is equal to 4x, and y equal to x is this straight line. This straight line is y is equal to x. So the region bounded by these two curves is this one. Region bounded by these two curves is this one. Okay, this is the region D. In this region we have to evaluate this integral. So how we will put the limit? We will put the limit, we consider the one strip, right? Consider one strip. This strip is either parallel to the y-axis or parallel to the x-axis, whatever strip you may consider. But when you put the limit, see here, if we move this strip, sweep this strip, the lower part become this one and upper part become this one. And what is this point? Y equal to x. Then what is y square? Y square is equal to 4x. If y equal to x, okay, y square is equal to 4x, y equal to x means y square is equal to 4y. It implies that y equal to 0 and y equal to 4. Then x equal to 0 0, x and y 0 0, and x and y is 4 4. Okay, these are to the point of intersection of this straight line and parabola. Okay, so if we consider this strip moves to this lower part and upper part up to 4. Okay, and strip is moving parallel to the y-axis. Okay, so first limit is y equal to 0 and y equal to 4. Okay, lower limit is 0 and upper limit. Now see the curve. See the curve is this one. Okay, curve is this one and one curve is this one. So lower part of the strip is lies on the parabola. And what is the parabola? Y square equal to 4x. Right? Then what is x? X is equal to y square by 4. Okay. And what is the upper part? Upper part lies on the straight line. What is x? X is equal to y. Okay. So x equal to this and x equal to y. And what is the function? X square plus y square. And d, with respect to which we have to evaluate, since the limit of the internal integral is function of y, so we have to evaluate with respect to x first. This is the first and then dy. Okay, now you can evaluate this integral easily. Okay, let us see another method. If we consider the strip parallel to the y-axis, then what happens? Okay, okay. Y square is equal to 4ax. This is the parabola. Y square is equal to 4x. Sorry, 4x, not 4x, 4x. And y equal to x. Y equal to x is this one. Okay. So region is this. Now consider the strip parallel to the y-axis. Okay. If we consider this strip, then first limit is x. Why? Since if we move the strip, lower portion is this and upper portion at the 4 4, and lower is this one and upper will goes to up to 4. So x equal to 0 to x equal to 4. And what is the lower part of the strip? Lower part of the strip is this one, y equal to x. So y equal to, and upper part of the strip is this one. What is this? This is the parabola, y square equal to 4x. Then what is y? Y equal to 2 root x. Okay, x square y square dx dy. Okay, this is I. Now you evaluate this both the integral, this one and previous one. The value of the integral is same. Okay, now come to the second example. Evaluate this integral where the region is bounded by this one. Same problem. Okay. What is this? Y square equal to x square equal to y. X square equal to y means this parabola. Okay, and y equal to x. Y equal to x is this one. Okay, the region bounded by these two curves is this one. Now solve the equation. This is y equal to x and this one is x square equal to y. Okay. Solve the point. Point of intersection of both curve is 1 1 and 0 0. Okay, so consider the strip. Consider this strip. This strip is parallel to the y-axis. We consider the strip parallel to y-axis. The lower limit is this one and upper limit is this one. The lower limit will goes from 0 to 1. Okay, x equal to 0 to x equal to 1, and lower portion of the curve is lies on this part, that is the parabola, and parabola is x is equal to y square. So this limit is x and this one is y equal to x square. Why? Since lower portion of the strip is lies on the parabola and upper portion of the strip is lies on this. The upper portion is lies on the straight line y equal to x, y equal to x, right? xy dy dx. Okay. So first evaluate with respect to y and second evaluate with respect to x. Okay. Again, if we change the order of integration, means with respect to which we are evaluating this integral. This integral we have be evaluating with respect to y first and then x. Now change the order of integration means evaluate this integral first with respect to y and then x. Okay. So let us see. Consider the strip. Wait 1 minute. Consider the strip. Consider the strip parallel to the x-axis. Okay. Now this lower portion of the strip will come up to 0 and upper portion will go up to y. So y equal to moving in this way, downward to upward. That y is equal to 0 and y equal to 1. And lower portion of the curve is lies on this straight line y equal to x. So y equal to x and upper portion lies on the parabola y equal to x square. Okay. Then what is this? xy, x plus y into xy. Okay. No, please wait 1 minute. The internal limit is not correct. So internal limit is not correct. We have to put in the form of, see, lower portion is lies this one. What is the equation of line? Y equal to x. So x equal to y and upper portion lies here. So x equal to square root of y. X plus y, xy, and first we have to evaluate with respect to x and then dy. Okay. This one. Evaluate this integral. Value of both the integral are same. This is also 3 by 56. You can evaluate it easily. Okay. This is the evaluation of the integral when the region of integration is bounded by the sum curve. Okay. Now let us see this one. What is this? Double integral over d x square dx dy. What is dt? Is the region bounded by this curve. Xy equal to 60, y equal to x, y equal to 0, x equal to 8. Okay. Now see. First we have to plot the region of integration. The region of integration is bounded by the curve number 1 xy equal to 16, it is the rectangular hyperbola. Y equal to x is a straight line passing through the origin inclined with the x-axis at 45 degree. Y equal to 0 is the x-axis. X equal to 8, a straight line parallel to y-axis at a distance 8 from the origin. Right? These four curves, the region is bounded by these four curves. Now let us see the figure. See, this is xy is equal to 60. Okay. Now y equal to x. And y equal to 0. This straight line is y is equal to x. And y equal to 0 means x-axis. This is y-axis. And x equal to 8. X equal to 8 is this one. This straight line is x equal to 8. The region bounded by these curves, this one. The region bounded by these curves is this one. Now, see, if we consider a strip parallel to x-axis or y-axis, let us see by one example. If we consider strip parallel to y-axis, what will happen? See, the lower portion of the strip will come here. What is this point? This point is 0, 0. And what is this point? This point is 8, 0. And upper portion will go up to 8. Okay, no problem. This will go up to 0 and this will go up to 8. Okay. What is the lower portion of the strip is lies on this straight line and upper portion of the strip is lies on the hyperbola. Okay, if this strip will sweep, okay, if this strip will sweep now, then from hyperbola it will sweep up to this part also. It means upper portion to certain time it lies on the hyperbola and certain few times it lies on the straight line. Few times lies on the hyperbola and few times lies on the straight line. Then what we will do? We have to do nothing. We have to do one thing, that divide the region into two parts. Okay, say this one. This is the region D1 and this one is the region D2. So this integral d x square dx dy is converted into two part, d1 and plus double integral d2. Okay, so we have to put the limit of this and this, right? So consider the strip parallel to the y-axis, strip parallel to the y-axis. Now see, first this integral d1. Okay, first we are talking about d1. The lower limit will come here 0, upper limit will go up to this point. What is this point? See, y equal to x, this is the intersection of the point curve, this is the intersection of the curve y equal to x and xy equal to 16. So y equal to x means x square equal to 16, so x equal to 4 and y equal to 4. Okay, so this point of intersection is 4. Now this strip will go to 0 at the lower part and upper part it will go up to 4, so 0 to 4. Okay, so lower portion of the strip is lies on this one, y equal to 0, and upper portion of the strip is lies on this one. What is that? Y equal to x. Okay, y equal to x. This is x equal to 0, x equal to 4. This one is y equal to 0, y equal to x, and x square dy dx. This is the first part. First part means first integral. Now come to the second integral. What is the second integral? The second integral is, okay, consider this strip. This will go lower part up to this one. Okay, in region D2, we are talking about region D2. Lower part will go up to 4. It means x equal to 4 is the lower limit, and upper part will go up to x equal to 8. So x equal to 8 is the upper limit, and lower portion of this strip is lies on this straight line, and this straight line is what? Y equal to 0. Y equal to 0. And what is x? The upper portion is lies on this one. What is this? This is the rectangular hyperbola. So what is y? Y is equal to 16 by x. So x square dy dx. Okay, evaluate these two integrals are easy, not difficult. Now evaluate this integral, right? You will get your answer for this. Okay. Now we will stop here. In next lecture we will continue from the triple integral.